Food safety is a scientific discipline whose aim is to keep humans safe from any disease coming from any eaten food. One of the priorities of the European Union is addressed to ensure the health of humans, animals and plants at every step of the food production processes, the so-called from farm to fork pathway. This goal is pursued by preventing food contamination and promoting food hygiene, animal health and welfare. Another important issue addressed by the EU is keeping the consumer informed about both the food safety policy and the food law adopted so far. Having a common food safety policy throughout the EU's countries is a crucial point in view of the fact that much of the food we eat crosses borders. Indeed, the EU is a single market and goods, including food, can be sold freely. The basic principles for the EU food safety policy are defined by the General Food Law adopted in 2002 and deals with several food safety related issues covering the whole food chain, from animal feed and food production to processing, storage, transport, import and export, and finally retail sales. Another crucial point for the EU food law is to establish the principles for risk analysis that regulate scientific and technical assessments implemented in order to ensure a proper protection of humans, animals and environment. Scientific advices about food safety are addressed by the European Food Safety Authority that responds to the requests from the European Commission, the European Parliament and the EU member states by organizing its work programs according to emerging priorities based on specific needs. The scientific advice is provided by EFSA's scientific panel and scientific committee composed of members selected by an open selection procedure. The main goal of the authority is to monitor and analyze scientific data and information of biological hazards, chemical contaminants, food consumption and emerging risks. Lastly, EFSA produces scientific output addressed to both the scientific community and to the consumers. The EU requires that foodstuffs such as meat, milk or eggs must not contain residue levels of veterinary medicines that might represent a hazard to the health of the consumer. Regulation 470/2009 laid down the rules and procedures for the establishment of the maximum residue levels, MRL. The MRL is the maximum allowed concentration of the residue in a food product obtained from an animal that has received a veterinary medicine. Before a veterinary medicine intended for food-producing animals is authorized in the EU, the European Medicine Agency, EMA Committee for Medicinal Products for Veterinary Use, evaluates the safety of its pharmacologically active substances and their residues and recommends MRLs. A more technical surveillance is carried out by means of rigorous checks in order to ensure that all products entering the food chain meet relevant standards. They include tests for harmful residues from veterinary medicines, pesticides and contaminants such as dioxins. For this purpose, one of the roles of the European Commission is to verify the effectiveness of the control system implemented at national level. For this purpose, the Commission Department DG Santé, Directorate General for Health and Food Safety, supervises the official controls carried out by member states in the frame of the multi-annual national control plans, MANCPs, in order to check their compliance with the EU standards. The MANCPs contain general information on the structure and organization of the system of feed and food control and of animal health and animal welfare control. Furthermore, the plans must specify the instruments and structures, including the personnel and material resources available for the fulfillment of the objectives. Chemical analysis for the detection of veterinary drugs, hormones and contaminants in food are performed under strict legislation rules, ensuring the highest level of food safety, e.g. MRL for veterinary drug. At present, the MANCPs of EU member states addressed to residue surveillance are essentially based on the identification of banned molecules by analytical methods. However, the official results reported a very low incidence of non-compliances for illegal growth promoter treatments in food-producing animals. This could be due to the fact that chemical assays are not able to detect compounds of an unknown chemical structure or present at very low levels. As a consequence, there is the need of innovative and sensitive methods able to detect a broad range of substances based on the detection of the biological effects exerted by each category of molecules, biomarkers, rather than only on their chemical structure. Therefore, the detection of these effects on the animal's physiology represents a promising way for the development of a new, rapid and cost-effective tests to screen the misuse of anabolic agents. In addition, the EU operates a Rapid Early Warning System, RASP, Rapid Alert System for Food and Feed, to protect people from food that does not comply with European food safety rules. This system also spots whether foodstuffs contain banned substances or excessive amounts of high-risk substances, such as residues of veterinary medicines in meat or carcinogenic coloring in food. When a threat is spotted, alerts go out across the EU. Blocking a single batch may be all that is needed, but all shipments of a particular product from a farm, factory or port of entry will be stopped if necessary. Products already in warehouses and in shops may be recalled. Food for human consumption, unprocessed, partially processed or processed food, must be subjected to the necessary hygiene rules during production, processing, storage, distribution and preparation. Food safety is a scientific discipline describing handling, preparation and storage of food in order to prevent food-induced illnesses, which may cause from mild gastrointestinal symptoms to life-threatening human health conditions. The contamination of food represents a major concern for food safety because of the emergence of new pathogens based on the ability of microorganisms to adapt and change, but also because of changing modes of food production, preservation and packaging that can result in altered food safety hazards. Among the infections are foodborne diseases, which result from consuming and drinking water and products of animal origin contaminated with pathogenic microorganisms such as viruses, bacteria, parasites and fungi, many of which are zoonotic. The European Food Safety Authorities define zoonosis an infection or a disease that can be transmitted directly or indirectly between animals and humans, for instance by consuming contaminated foodstuffs or through contact with infected animals. Earlier studies have estimated that more than 60% of infectious diseases in humans come from pathogens shared with wild or domestic animals. Foodborne zoonotic diseases are infections and diseases that are naturally transmissible between animals and humans through contaminated foodstuff. For this reason, it is essential to manage the implementation of good agricultural and handling practices, as well as educational programs. Researchers around the world indicate that the majority of zoonotic disease cases are related to animal bred for food purposes. Around the world and by continents, there are different governmental, private and research organizations that are monitoring the emergence of foodborne diseases. Nowadays, it is essential to have in-depth knowledge about potential hazards and biosecurity aspects associated with food safety. Therefore, a major policy priority worldwide is the promotion of a high-level food safety in order to reduce the incidence of foodborne diseases. In order to reduce the activity of microorganisms, bacteria, mold, yeasts, whether pathogenic or spoiling, preservation is necessary. Food preservation prolongs the life of food by avoiding food waste and maintaining nutritional value. Preservation makes food available in off-seasons, saving time in procurement. The main principle of preservation, maintenance of asepsis, is using methods that have bacteriostatic or bactericide effects on contaminant bacteria. Bacteriostatic methods include refrigeration, dehydration, glazing, salting and adding some chemicals, while bactericidal methods comprise heating, irradiation, smoking and canning. Traditional food preservation techniques include heating, freezing, fermentation, drying, salting, and so on, or using antimicrobial agents integrated either directly into the food particles or incorporated into a polymer film as an antimicrobial packaging system. Storage at refrigeration temperature may result in unsatisfactory reduction of pathogens such as E. coli, Listeria monocytogenes, and Yersinia enterocolitica, but the inclusion of a maturation period, fermented sausages, above refrigeration temperature may increase the safety of non-heat treated food. Traditional techniques can preserve food products, but recontamination may occur. Novel antimicrobial packaging systems can suppress the activities of targeted microorganisms that are contaminating food. Active antimicrobial packaging is used as a system that modifies the environment inside the food package in order to maintain microbial safety, enhancing extension of shelf life and sensory qualities. Having control of possible risks associated with microbial hazards on foodstuffs is a priority. Consequently, technology and managerial control activities are crucial. For this reason, it is extremely relevant to adopt quality systems through the production chain to prevent damage to public and animal health and the environment. Furthermore, the roles of the legislation systems also have great significance in all countries, which implies the availability of specific standards for biological, physical, and chemical risks. Another aspect focuses on the need for networking to spread information and staff training at local, regional, national, and international basis for the application and operation of proposals with hazard and risk principles to guarantee food safety. Moreover, it is important to implement effective biosecurity strategies to safeguard food value chain on a global level. A global perspective into biosecurity policies and the approaches to reduce the risks and increase the benefits of the international trade and globalization is required.
Analytics Engines specializes in data integration, data management, machine learning, artificial intelligence, the operationalization of workflows, in-depth analytics and visualizations. Analytics Engines supports clients throughout their data journey with full-stack, customer-facing solutions designed to be scalable and deployable on-prem or via the cloud. Their high-value, end-to-end solutions have shaped data-driven decision-making within government, biomedical science, media, healthcare, tourism, and the higher education spheres. According to one common definition, food fraud is a deliberate and intentional substitution, addition, tampering, or misrepresentation of food, food ingredients, or food packaging. Detecting food fraud is extremely challenging because foods are exposed to risk at almost every stage of the supply chain. Food fraud has the potential to be a risk to public health and can be detrimental to consumer trust and confidence in food. For example, following the horsemeat scandal in 2013, consumer trust fell not only in beef products but also in the food industry more generally. This led to the UK government commissioning the Elliott Review into the integrity and insurance of food supply networks. One of the recommendations arising from this review was the need to establish a shared focus between government and industry to collect, analyse and disseminate information and intelligence. Such an intelligence hub will be central to the production and sharing of horizon scanning analysis of commodities and markets considered most at risk from crime, due to factors such as trade route complexity, price fluctuations, crop failures, fishing restrictions, development of premium markets, and criminal ingenuity. The EIT Food Fortress project aims to play a key role in gaining consumer trust through improving the transparency of the supply chain. By using a combination of technologies such as blockchain, multi-analytical tests, and predictive analytics, EIT Food Fortress aims to facilitate a rapid, reactive and proactive risk management approach, specifically targeted at two supply chains, beef and also herbs and spices. Analytics Engines, one of the project partners, is building an application to help food manufacturers and processors understand and manage risks in their supply chains. Powering this application are visual and predictive analytics designed to assess risk and predict food fraud in these supply chains. The information gathered can then be displayed via interactive web-based dashboards and reporting tools. Data visualization plays an important role in analytics to allow exploration, communication and analysis of large complex data sets. Importantly, these need to be well designed to make it easy for our eyes to find the story the data is telling us, to extract insights and draw conclusions. Effective and impactful visualizations should be customized to the needs, interests and skills of the users to capture and hold their attention. Analytics Engines is adopting a human-centric design approach which aims to provide the maximum possible utility for EIT Food Fortress and its end users.